basically the answer. So now we move on to the next questions. And so the next questions here, if we go back here, then we are on question 5. Now, question 5 here, if you look at it properly, so question 5, I'm going to try to get it all. So get the entire drawing in there. So let's hope it will transfer. So when we look at this, then there we go. Thank you. So now we have this one here. And so let's work it out. So firstly, let's first read the entire statement and then we're going to start looking at the questions. So we have 5.1 and question 5 says the graphs of f of x is equals to negative x squared plus 4 and g of x is equals to x minus 2 are given. A and B are x-intercepts of the graph of f. C is the turning point of f. The graph of G meets F and B and E, D is the y-intercept. Okay, so all those letters have something to do with something. Okay, now let's go to the questions. I'm going to just copy and paste all the questions and bring it to the side. So, yeah, can I copy all these questions? Yes, I can. The very last one there, it's a drawing. So, yes, I can. So let's try and copy everything in. Oh, the first one here, we need to do a lot of work. It's 8 marks, and basically they say they want us to determine the coordinates A, B, C, D, right? So let's start by pasting this, and I'm not gonna paste it fully, right? I'm gonna, yeah, let me just open it up. Okay, so there we have 5.1. 5.1 is 5.1.1. And so they're asking us, we need to determine the coordinates of A, B, C, and D. There's A, there's B, there's C, and then there's D, right? So the easiest one right now is definitely, okay, let's just start with A. We're gonna do them in order. So let's look for A and B. So A and B are actually x-intercepts of F. F being f of x is equals to negative x squared plus 4. And that is basically a parabolic function. Now, because they are y-intercepts, oh, it's 4 there. So this is 4. So because they're parabolic, we will let, right, what? Because you want the x-intercepts, y is equals to 0, right? So if y is equals to 0, then it's actually 0 is equals to negative x squared plus 4. And I'm going to take the x onto the other side. So then that just becomes x squared is equals to 4. Oh, luckily, I can square root, right? But when I square root, it's plus minus. So that becomes plus minus 2. And so it's quite clear that we have A, and A, when we go back to the graph, which side is it on? It's on the negative side. It's negative 2. And actually, you can actually see it there on the graph. So it's negative 2 square root 0. And B is 2 of 0, right? So we have A and B very easily, very quickly. Okay. And C, let's see, C. So C is a turning point. Now the turning point is quite easily seen because it's the y-intercept of f of x. And the y-intercept, when you just look at the graph, it is just at 4. So we know it's actually 0 maps 4. But when you have to do it, actually calculate it, how would you get it? You would first say, let's find, right, x is equals to 0, right? And that would be f of x of 0, right? And minus 0 square plus 4. And definitely that would be just 4, right? That's equals to f of 0. And so C is 0 maps 4, as I said. So we know that it would be 0 maps 4, but if you had to actually calculate it completely, that's how you would have done it. And then we have D. Now, D is what exactly? Now, D is actually going to be 0 maps -2. But how do we get that? How do we get that? We are looking at now g of x. So we say g of x is equals to x minus 2. And then you would say you'd let x to be equal to 0, right? Because we're looking for the y-intercept. And so this is 0 minus 2. And then the answer there is just minus 2. And that's g of 0. And so d is equals to 0 maps minus 2. And that would be your intercept there. So d, the coordinate of d would be 0 maps minus 2. Simple as that. Okay, so you got them all quite easily. It's just intercepts, very straightforward calculations. But also at the same time, you could have just identified it by looking at the graph itself, right? Just by looking at the graph itself, you would have known what the answers are. Now they say determine the coordinates of E. Now determine the coordinates of E. Where is E? Now E is down there, right? This is probably at 3. Now I know you could have checked this and said, okay, 3 and 3 on both equations and see if they give it the same answer. If they do, then it's equals to. But in this case, then the first thing we're going to do is let's try and actually solve it. So what does this mean? E is where? It's right over there, right? And this is G crossing F, or intercepting or cutting F. So they're both cutting each other at that very point. The Y is actually equals to each other. So that actually means F of X is equals to G of X. And that's basically what we're solving. But then what is F of X and what is G of X? G of X is X minus 2, and F of X is minus X squared plus 4. So it's minus X squared plus 4. Okay. And so in this case, then what do? We just simplify. So we just simplify. So this becomes negative X squared minus X. And this is plus 4 minus 2 is equals to 0. So I took everything and put it on the other side. So then we have minus X squared minus X plus 2, that's equals to 0. But then since this is negative, we rather work with a positive. So we multiply everything with negative, so it's 0. And so this is X squared plus X minus 2. And then the only thing we must do now, what is the factorization? So this is a quadratic, so there's going to be 2 brackets, right? And these 2 brackets. And then we ask ourselves, what are the 2 numbers that we multiply together to give us negative 2? But when we add together, it would give us 1, positive X, right? Or positive 1. So basically then it would be 2 and 1. 2 times 1 is 2, but one of them has to be negative, right? So it's going to be 2, positive 2, and minus 1, right? So positive 2 and minus 1, because when we add this together, 2 plus negative 1 would give us positive 1. So that is definitely our factorization in that case. So now we have X plus 2 is equal to 0. That's minus 2. That's X. Or, right, X minus 1 is equal to 0. And that's just 1. Right. Now, those are the 2 answers. But remember, we are not looking for 2 answers, but we're looking for 1. Because E is only at 1 point, right? B we already have, which is at what? It's that 2. It's that 2. So it's at 2. Oopsie. There's a mistake here. Just notice now. Okay, so let's try it again. So this is negative, that would become positive, right? So that's positive, and that becomes 6. So this is 6, not 2, right? And that becomes negative 6, right? And negative 6, then it's positive, it's negative 2, right? -2, and positive, no, yeah, it would be -2, and this would be +3. Okay, so there's a mistake there. Okay, so this is negative, and this here is +3. So there we have fixed our mistake right now. So it's 3. So when we go back and look at this, oh, this is supposed to be positive, not negative. Negative, so it's positive. So it's +2. So when we go back and look at our solution, so we had x is equals to 2. And as you can see, this is where f of x and g of x are equal. So it's x is equals to 2. And when we go back down and see that here it's 3, right? It's supposed to be -3, not +3. Sorry. So this is -3. So it's -3. And this would be -3. So this does correspond. This does look like -3, and that is definitely true. So as you can see, as I've made this mistake, it was helpful that when we go back and actually compare our actual solutions to what we see, we can see whether or not we've made a mistake, as I've made a mistake here. So there we have basically these 2 points. But this point at 2, that is B. But this point at -3, then that is E, right? But this is -3, right? But now we need the Y because it's not a Y-intercept or an X-intercept. So how do we get the Y? How do we get the Y? Because as you can see, this is not an X or Y intercept. E is not an X or Y intercept. So we just take any of the 2 equations. So we know that X is -3. So -3 minus 2 would give us what? -5. Now let's see if this corresponds to -5 on our graph. Yes, if you look at it, yes, it would be -5 and 3. So we can see that it's probably true. So we've just gotten that 6 marks, right? Now 5.3. Oh, so you would have said I use g of x, -3, and this is -3 minus 2. That's just -5. Okay, so this is 1.3, 1.3. And then they ask us the length of CD. So the length of C to D, from C to D. This sounds quite straightforward. So for this one, the length of CD, if you think about it, even with the mark allocation, it's just 2 marks. We can just probably count it on the graph. So this is 1, 2, 3, 4, 5, 6. So that's 6 spaces from C to D, from C to D. So it's 6 spaces down from C to D, right? So this is just 6 spaces. So this is CD is equal to just 6 units. Right? So we say 6 units. And don't forget to write units when you are asked about the distance or the length when you're doing your functions. Okay, so that's 1.5.3. Okay, the next one, 5.2. So 5.2. And my fingers are tired now. So 5.2. So 5.2.1 says the domain of G, right? So the domain of G. Now, what is a domain? Remember that a domain is basically all the numbers, right? It's, oops, a domain. So the domain of G is all the X values, right? So let me actually write this properly. I'll say domain. So this is 5.2.1, and this is domain of G, right? And so domain of G is equals to what? So domain of G, what is domain of G equals to? Remember the domain or range, domain is actually asking you, what are all the X values that this graph goes past? If you look at this, this is going continuously and this is going continuously down. So this most probably is going to go to negative infinity to positive infinity. So you can write it as an interval notation of negative infinity to positive infinity, right? With open brackets. Or you could have said the domain is an element of all real numbers, right? Of all real numbers. So basically all real numbers, all the numbers from negative infinity to positive infinity. Same thing. 5.2.2. And this is called interval notation. And here it's set builder notation. 5.2.2. So 5.2.2, what is the range of f? What is the range of f? Now, with the range of f, remember, this is a parabola. So in actual fact, when you look at it, it doesn't go any higher than 4. So 4 is actually its maximum, right? And then everything else is its minimum because it continues just keep going down. So 4 is its maximum. So if it's its maximum, right, and we're looking for the range of f, right, then we could say, what is the maximum, right? And what is the minimum? So the minimum is that it starts off at negative infinity. And the maximum stops at 4, but 4 is included, right? So in set builder notation, we could have also written it as just being y, right? Our y values, y, that is less than, is just less than. No, it's not just less than, but it's actually less than or equals to 4. So anything less than or equals to 4 is basically your range. Simple as that. Okay. So then it's 5.2. And now we go to 5.3. Now 5.3. Now they actually tell us something. They say, looks like we have to create a new equation. So 5.3. So 5.3 says determine the equation of j if j x is equals to negative f of x, right? So this is actually quite easy. Now, whenever they actually give you something like this and you just need to make a new function of j, you take it as is, right? They say j is equals to negative f of x, right? But now we know what f of x is. What is f of x? F of x is minus x squared. F of x is minus x squared plus 4. So if it's minus x squared plus 4, then we just substitute it as is, but with the bracket. So you'd say minus negative x squared plus 4. And that would be our jx, right? So our jx, we need to simplify this. When we multiply each other inside, then it's x squared. When we multiply that inside, then it's minus 4. And that would be our jx, right? And basically, that's our jx, and we're done. Now we go to 5.4. Now, with 5.4, I think it's a drawing. So a bunch of words. Yeah, they say use the diagram sheet provided to sketch the graph, right? So to sketch the graph of k of x, which is equals to negative 6 over x, and h of x, which is equals to 2x, 2 to the power x, on the same set of axes. Show all the intercepts with with the axes and the asymptotes. Now, in this case, I actually will not write all this up, right? But what I will do is to draw it up, because I won't be able to draw all this up. So this would be minus 6 over x, and that's supposed to be equals to what? 2 to the power x? I think it's 2 to the power x, yeah, 2 to the power x. Yep, 2 to the power x, so 2 to the power x, like that. And I'm gonna create the graph using my laptop. Okay, so graph on both axes, and there we go. So this would be the graph, right? And this would be the graph right there. So the red one, oops. Okay, I think I need to do that again. So there we go. So this would be the graph. And so this being the graph, basically you can see that the red one is the exponential function, and the blue one and the purple one is going to be your hyperbolic function, right? So the hyperbola, there it goes, and the asymptote is on the x-axis for the hyperbola, right? And then for the also the exponential, the asymptote is on the x-axis. So this would be basically it. And they don't cross each other. They don't cross each other even once. So there's no intercepts. So that's the very answer that you have there, right? So basically, that's basically question 5. Question 5, I think that was the last question. Yeah, it was the last question. So now let's continue to the final questions, and this has to do with finance, right? So this is question 6. So question 6. So let's start off with the first one. I'm going to just take the first one on its own. So the first one on its own, the first one on its own, we got it. Right. Okay. So the first one on its own, it says, a boy's parents gave him 30,000 for his 21st birthday. His parents said that they had invested a sum of money on his 10th birthday. They had drawn at 13.5% per annum compounded interest for 11 years. How much was invested 11 years ago? So we need to figure out basically how much was invested 11 years ago, right? So in this case, if we have to try and invest it 11 years ago, how could you do this? Let's use the compound formula first. So the compound formula, we know we need to use compound, right? So it's A, P, and then that's 1 plus, what was it again? It's I, yes, it's I to the power A. Yeah. So that's the compound formula, right? That's the compound formula, right? So now, what do we have? He says a boy's parents gave him 30,000 for his 21st birthday, right? This is something he got on his 21st birthday, right? But this money started to be invested 10 years ago, 11 years ago, when he was 10. So we don't know what is the principal amount, or P. We don't know what was the present value that you're putting in for the future. So we are acting as if we're in the future and we have that 30,000. So our A is the accumulated amount, right? So 30 is our accumulated amount. 30,000 is our accumulated amount. 30,000. Okay, how many more zeros? Okay, and this is P, and then 1 plus I, and this is I, we rewrite it in terms of decimals, and so if you rewrite it in terms of decimals, this is 0,135, and that is all to the power what? Now this is compounded how many times? So this, they said, per annum. So this is compounded per year. So this is still just 11. Okay. And it's per annum. So this is going to be 1,135 all to the power 11. This is 50,000, 1, 2, 3. Ooh, I should have brought a calculator. So, but I hope it will be able to calculate this. So let's have hope. So this is 1,135 all to the power 11. Okay, so that's 1,135 all to the power 11, and basically we just get P. So P, then what would it be equals to? So let me calculate this using the laptop. Let's see. How powerful are you? Let's see, is it correct? Yes, correct. Yeah, I can't calculate it, but when you have a calculator, I think the answer would be 7,000, around 7,000, 7,450 rands, comma, 18, yes, 18, okay, so it's 7,450 and 18 cents. So basically that would be your answer in that case, right? So there, we got 6.1. right? We use the compound formula because they told us that it is it's compounded, right? So they told us that it is compounded. And so we know that we need to use compound formula. We need to use the compound formula. Now let's just take the rest of the questions. So let's take the rest of the questions, and we've just written an entire 100-page or paper out of 100. Not 100-page, but paper out of 100 in these few hours. Okay, so yeah, yeah, yeah. What you doing now? What you doing? Huh? What you doing? Hey, okay. Now we look at 6.2. So now 6.2, 6.2. Now it says what? So it says the sketch below represents Label's house that she bought in 2013. The price of the house accumulates at a constant rate annually. The x-axis represents the period in years, and the y-axis represents the price of the house in rands. Okay. So the price of the house in rands, the y-axis right there, and the period as the time, right? The years. So how much was Label's house in 2013? So how much was it in 2013? This money would be 20,000 Rand, right? So it would be 20,000 Rand. This is quite straightforward. So this would be 20,000 Rand, not 200 Rand, but 20,000 Rand. This is a car or a house. It's definitely a house. This is 20,000 Rand. Can't be 20 Rand. So this is 200,000 Rand, right? And so then the next question says, if the price of Label's house accumulates like this continuously, is the interest earned simple or compounded? Now, this one here, it's actually quite interesting because you see this graph, and this graph is actually just a straight line going upwards, meaning it's accumulating. Yes, it's growing, right? The value of the house is growing. But because of the way it's growing and the way it's growing as a linear graph. It's a linear graph. Because it's growing as a linear graph, then we know that this is simple. This is a simple interest. This is simple interest that is being earned. It is simple interest that is being earned because it is growing as a linear graph. If it was like this, if it grew like this, then it would be compounded. But it's not compounded. It is linear because it's a straight line graph, right? So those are the differences between the two when you see a graph like this and they ask you, explain your answer. And you just explain it by saying that one, it is simple interest. It's simple interest that is being earned because, as you can see with the graph, simple interest grows as a linear or a straight line. And compound interest, it's a curve, right? Okay, so basically that's it, right? That's 6.2.2. Now, 6.2.3, how much will Label's house cost in 2013? So how much will it cost in 2013? In 2013, 2019, in 2019. So they're asking us how much will it cost in 2019? Now, luckily, we need to find what it cost in 2019. We know definitely maybe just above 35,000, 350,000, right? But how can we calculate this, right? There isn't really much that they told us in terms of what we have. So the best way we could do this, right? The best way we could definitely do this is by just adding and looking at the graph itself. So when we look at the graph itself, the first price was 2,000. And then this is probably half of that. So this would be 2,200 and okay, yeah, 225, 225,000, right? It will be 225,000 at this point, and then it's 250,000, and then it's 200 and Yeah, so as you can see, then it becomes 275,000, then it's 230, then it's 225,000, and then it's 350. That's the pattern that we saw. So definitely we can say at 6.3, this would be 3,500. Right. Then they say, hence calculate the interest per annum, right? So calculate the interest per annum. So luckily, you're lucky that in 6.2.3, there's actually a pattern that was being followed. If you looked at the graph properly, that it was first 200,000, and then it's 225,000. It's 200,000, and then it's 225,000, and then it's 250,000, then it's 275,000, and then it's 300, then it's 325,000. And so obviously the next one would be 350,000. Okay, so luckily we were able to find that, and we know what it was at the very beginning. We know what it was in 2019, but now they're asking us how much, hence calculate the interest rate per annum. But we already also answered what type of formula that we have to use, and that is the simple interest formula. So we say simple interest is A and P is it's 1 plus IN, right? Plus IN. And what we are looking for is your N, because we actually kind of know how many years there are, right? We're looking for I, sorry. Because we already know how many years there are. So he invested in 2013, so it's 1, 2, 3, 4, 5, 6. So 6 years. So we know that it's 6 times I, interest rate I plus 1. The previous value, or the starting value of this money was 200,000. And now the accumulated value after the 6 years is 350,000. And there we go. Okay, so now we just need to solve for I. So there we have, it's 35, 1, 1, 2, 3, divided by 2, 0, 1, 1, 2, 3. And then it's going to be 1 plus 6I on the side. And so actually, if we simplify this, I think this is going to be 35 over 20. But 35 over 20, I think 5 goes into them. So 35 is 5, 10, 15. That is I think 30, 25, 30. That's 7 at the top. So it's 7 over, and 20 would be 5, 10, 5, 10, 15, 20. That's 4. So it's 7 over 4. So it's 7 over 4 as a simplified fraction form of this, because these zeros would just cancel each other out if you think about it, right? Right? And then it's 35 over 20, but 35 does how many times? 5 goes into 35 how many times? 7 times. And 20 goes into 5 4 times. And so that's why we have 7 over 4. And then here we just take the 1, so it's minus 1. And then that's 6I, right? And this would be 7 minus 4. 4, that's 3 over 4. So this is actually 3 over 4. All right. And then that's 6I. And then 6I, so we divide this by 6. And so our I would become what? So what is our I? So I've simplified it to the furthest point. Now I'm just a bit tired, but yeah. So let's get the answer there. And the this right there is division, my G. So done, action, evaluate that, please. So that is 1 over 8, and that's actually 0, 125. So this is 0, 125. But 0, 125, that means it's 12.5% per annum, PA, right? Simple. Okay, so basically that's it. That's that question. So we've gotten 6.2.4. Now we go to the very last question, like literally the very last question. So it says, Paul buys a car worth 385,000 in 2013. What value will the value of the car be at the end of 2018 if the car depreciates at 6% per annum straight line depreciation? Now, as I explained about straight lines, they just said straight line depreciation, meaning this is tied to what? To simple interest, right? So this is simple interest. So we're still going to use the same type of formula of simple interest. This is 6.3. So we're using the same type of formula, or almost the same, but because it's depreciation, right? Because it's depreciation, it means that it's not plus, but it's minus in, right? Like that. Instead of plus, it is minus. This is appreciation, and this is depreciation. Okay. So now they're asking us how much would it depreciate. So we actually take the biggest value, which is 385,000 as our present value, right? And then minus I, and our percentage in this case is 0.06. And our number of years from 2013 to where? So from 2013 to 2018. So to 2013 to 2018, that's about 5 years. So let's see, 1, 2, 3, 4, 5. So it's 5 years. So that's 5 years. So 5 years. And basically, we will calculate now how much did it depreciate. And depreciation means what? Decreased over those years. So how much did it decrease over those years? Okay, so let me fix this. Oh, okay, so this is the problem right there. Okay, this is right there. We're almost there, 100%. There we go. So there we have it. Okay. Okay, still a bit of a problem. Okay, let's see. So I want to fix this. I'm gonna say this is multiplied. Multiply it. That. And so this is gonna be straightforward. So let's calculate it. And when you calculate it, what do you get in energy? So no. It's not to the power 6. Just 0.6. Yes, 0.6. 0.6. Yes. There we go. It's fixed. I can't calculate it. Okay. So this can't calculate it, but let's see what we can do. How else can we get this answer? Oh wow. After all that, my calculator just doesn't want to calculate this. Oh, it's because it's a big number. Yes. Big number that you have over there. Okay, so let's do this. So it's gonna be 3, 8. Okay, let me actually just calculate it with my calculator. So otherwise we'll never finish. So as I calculated, so it's 300, it's 385,000 bracket 1 minus 0.6 times 5 and equals, so that is 2, 6, and that says what? 9, 5, 0. 0. So that is 269,500. So that is 269,500 rands. So that's how much money this particular item has lost over the 5 years. So over the 5 years, it has decreased to that amount, right? So This is the entire, literally, the entire, yeah, like the entire question paper. We have just written a whole 100 marks of mathematics paper 1 technical maths. So I'd really like to thank you for watching this video. I am absolutely exhausted. I hope you are as well. And I'll see you next time.